is a warm welcome from the 5G-ACIA. As the moderator of this, my name is Uwe Rundklau from Infineon. I'm also the Vice Chair of the Working Group 4, talking today live from Munich. And we will hear today set about the security aspects. Together with me today for the webinar series, Security Aspects of 5G for Industrial Networks. A warm welcome again to Ale Ezaki from Nokia, live from Munich, Germany, as well as Hideo Nishimura from Yokogawa Electric, live from Tokyo, Japan. With this, I will then hand over to you. Thank you.
Thank you, Uwe. It's great to be here. I'm heading security standardization in Nokia, and I was the rapporteur of the security work item we carried out in the working group 3 of 5G-ACIA recently. Together with my colleague Hideo, we will present to you the contents of this work item, as well as some recent developments in industrial 5G security since the release of the white paper. As mentioned, this work was carried out as part of the working group 3 on architecture and technology of the 5G-ACIA, and the main interesting point of this activity has been the fact that ICT companies such as mine and OT operational technology companies like my colleague Hideo's came together to compare requirements, to see the different characteristics of industrial versus telco networks in terms of security. And then we compared or tried to match the 5G security features that were relevant for OT deployments. We will reflect these aspects in this webinar, and we will also give an outlook of the next steps and where these joint efforts should go forward to. Now, here is our first poll. Which stakeholder group do you belong to? ICT, OT, academia, or others? Please go ahead. Okay, so the results are in. We have 45% of the presenters from the ICT industry. We have 33% from the OT industry, 15% from academia, and 3% others. So I see a good representation of both sides of the, let's say, ecosystem of industrial networking, and I hope our webinar will be beneficial for all. The second poll is about the regions. Which region do you come from? Basically Asia, Australia, Europe, North America, South America. Please go ahead. Africa. Okay, so the results are in. We have 13% representation from Asia and 87% from Europe. So we strive to have, let's say, a balanced representation. Of course, time zone dictates a little bit. Now, North and South America are still asleep. So let's say, otherwise, I'm sure it would have been another balanced view. But thank you for all the participants and for answering the poll. We will have a short one in the another poll in the middle of the presentation. Thank you. With this, I would like to hand the presentation over to my colleague Hideo Nishimura from Yokogawa Electric will be presenting the OT side of the equation. Hideo, I will scroll the slides as you prompt. Please go ahead. Thank you.
Thank you, Ali. And good morning, good afternoon. Again, my name is Hideo Nishimura from Yokogawa Electric, an automation supplier company. And as the first part of this webinar, I'm going to start with security characteristics of OT networks in general. An OT network is a mission-critical network for industrial automation control systems. And like other communication systems, security is a very important aspect of OT networks, particularly for operators of critical manufacturing infrastructure. And from my experience in introducing new wireless technologies for process automation to those operators, security often comes as the top priority concern, followed by other performance aspects such as reliability, latency, and so on. So the priority and characteristics between OT and ICT networks are somehow different. And so let me start presentation. And first of all, I'd like to emphasize that physical isolation is traditionally the first principle of OT network security. And industrial automation control systems are typically physically isolated from other networks, and a strict perimeter protection and access control are used to restrict flows of manufacturing operational data to the outside. The confidentiality of those operational data is crucial for most operators to maintain their competitiveness. And physical isolation also mitigates the risk of cyber attacks that could cause interruption of manufacturing operation. So when 5G technologies are widely adopted in OT networks for critical purposes, we may need to consider radio jamming as a new major threat against continuous operation. Disruption of production causes a big economic loss to manufacturers, and especially it is critical for safety critical process plants where an emergency shutdown of the plant is usually needed when automation systems become out of control in order to prevent a disaster such as a massive chemical explosion, and recovery costs for this critically huge. Please go to the next slide. And another security principle of OT networks is a single trust domain formed by users, processes, data, and equipment within the perimeter. Third parties, including even system integrators and automation suppliers, like my company, are typically not allowed to get within the perimeter except for minimum remote maintenance tasks. And within the perimeter, usually further operational duties are defined according to further operational boundaries are defined according to the operational duties. And appropriate segregation based on the need to know principle is one of the key requirements for protection of operational data. And according to this single trust domain principle, a 5G network operator also not be a part of the trust domain. Therefore, in the case where a third-party telco operates a 5G network for OT manufacturers, mechanisms such as end-to-end encryption and integrity protection would be needed to prevent access by the third-party network providers to OT's data. Please flip the slide. And in this slide, I also would like to mention the different authentication requirements between OT and telecommunication networks. Due to the existence of perimeter protection, strict per-device authentication mechanisms are generally not used in OT networks. In contrast, mobile networks based on 3GPP specifications mandate state-of-the-art authentication using secure hardware components for credential storage and processing. And a typical example of such hardware is a SIM card. The strong authentication mechanism provided by 3GPP would benefit to OT networks or in terms of enhanced authentication security. But at the same time, it would bring a new operational challenge to OT operators, which is management of credentials stored in secure hardware component of each wireless equipment. And please go to the next slide. And the security characteristics we have seen in the previous slides are usually required by regulation. And to prove compliance with those regulatory requirements, OT manufacturers usually receive associated certifications as one of the business imperatives. And so it should be recognized also by third-party network providers that any changes in network configurations must ensure the continuity of compliance. Otherwise, these certifications could be lost. And there are also regulatory requirements from the telco side, which example is lawful intercept. The 5G system has a set of capabilities that can be used for electronic surveillance, and this would not be applied to private networks, but public network operators would need to provide communication contents of specific users upon a formal request from authorities. So when planning to use a public 5G network as part of a OT network, both OT operators and telco providers must be aware of each side's regulatory requirements and should carefully assess if and how these requirements can be met. And please go to the next slide. The characteristics I have talked about so far are based on the traditional principle of OT network security. So here I also try to talk about the latest trends driven by the momentum of digital transformation of the industry, such as Industry 4.0, Industrial Internet of Things. And according to these trends, more interactions between OT and IT systems are unavoidable in order to embrace the latest digital technologies such as artificial intelligence in order to implement more advanced and sophisticated optimization solution for manufacturing operation. But from a perspective of security, it means that the bar for security control has been raised. And in order to handle these increasing security threats, the strategy of defense in depth is being adopted for OT networks as well. And in this concept, not only security features at the single network layer, but multiple layers of security features at the upper layers are used in combination to improve overall security. And based on this concept, the OPC UA framework, which is one of the most important information exchange standards in this industry, offers security features within the different upper layers to ensure end-to-end security agnostic to the underlying communication system. But of course, other security features at the lower network layers, including 5G security features, can be also employed additionally for enhancement. And in the next slide, here I'd like to introduce IC 62443 as the most important security standards for OTs. IC 62443 is the leading series of international standards on cybersecurity for industrial automation control systems. The standards are based on industry security best practices and so provide practical guidance and a comprehensive list of requirements for the 3 different roles in manufacturing: asset owners, which are operators of factories and plants, and system integrators who provide automation system, including network, and automation device suppliers who provide automation components comprising the system to asset owners. And IC 62443 also defines different security levels in order to provide flexibility to be applied for different various automation systems requiring different security levels. Higher security level requires a larger number of and more advanced requirements to be implemented. And once target requirements are identified through individual risk assessment, these requirements must be implemented using security technologies available in the market. And for 5G security features, such as state-of-the-art authentication, network slicing, etc., can also be considered as new part of security toolbox to implement those 62443 requirements, especially more advanced requirements for higher security levels, such as hardware protection of authentication keys. And please go to the next slide. And this is the last one for my part. And here is an example of OT network configuration for process plants, which is designed based on the standard automation pyramid architecture and the concept of security zoning, also defined in IC 62443. A security zone is a logical group of physical, logical, informational assets, and each security zone has its own functionality. In this example, safety control, process control, and operations management within each plant, and the enterprise function in headquarters. And assets in one security zone have the same security requirements and are usually owned by the same responsible organization. The idea of security zoning is to divide the complex or large OT networks into multiple security zones according to the required level of security. And IC 62443 also introduces the concept of a conduit to cover the security aspects of flows of information between zones. A conduit is a grouping of flows of information allowed to cross a border between zones. In this example, 2 conduits are defined within plants, and the enterprise conduit connects the headquarters and its 2 plants. Looking at the safety control zone in the plant, as the safety control system is used for an emergency shutdown, it must be protected even when an attack to the process control zone is successful. And so the safety conduit connecting these 2 zones must be designed to heavily restrict the loss of information entering into the safety control zone, except for minimum informational monitoring information. And also you can see the conduits are designed to prevent direct flows of information over multiple levels of the automation pyramid. And such a design is considered as today's best practice for OT network security. And in most cases today, security zones are implemented as physically separated networks. And a firewall is employed as conduit implementation for validating any communications across different networks. But with the novel network slicing capabilities offered by 5G, security zones could possibly be implemented as logically isolated network slices. But I will stop now and hand over to Ali for more details.
Thank you very much, Hideo. Much appreciated. You have helped us understand the security requirements from an OT side and the potential state of or current state of the art implementation of security practices inside OT network architectures. So this forms the basis of our presentation as to what requirements and current implementation conditions 5G network should conform to, and what are the security features and the toolboxes available that can implement these requirements and adapt to the applicable network architectures. So thank you very much for that. In the second part of the webinar, I will present the applicable security functions and features of the 5G system, and we will have a look at the different network implementation scenarios and how one OT, let's say, operator could choose from different available networking solutions. But before we go to that, we have another poll based on what Hideo has kindly presented, and of course based on your own experiences. Would you please help us understand your perspective? What do you consider to be the biggest security challenge in the adoption of 5G for OT networks? Is it network isolation, radio jamming, trust with 5G operators, or compliance with regulations? What is the biggest security challenge from your perspective? Please go ahead. Okay, the results are in, and it's a rather, let's say, well spread overview. 29% of participants identified network isolation, 27% radio jamming, 27% trust with 5G network operators, and 7% compliance with regulations, and 7% don't know was selected. So indeed, this also could be an indication that OT network implementations and deployments are very specific to the process they are implementing, and the security risks and let's say the threat surface and the applicable let's say risk is different in each instance. So I'm glad we have this distribution, and I'm hoping that 5G security solutions will be able to answer to most of them. Thank you for your participation. Let me continue. The first concept we would like to introduce in the 5G implementation of industrial networks is the non-public network scenarios that we have been working on. This is essentially an alternative network architecture to what we are used to in the public network, meaning the telco operator networks that end users use every day for their general communication needs. In non-public networks, there are different implementation options that we can identify, and the main idea is how much integration there is with the public network of a telco operator. You are an OT operator who wants to implement the operational 5G network, and you have your options depending on how much integration you want with the public network. And of course, this in turn is generated through the capacity of each operator to run their own network. The first one is called the standalone non-public network. For those of us familiar with the 5G deployments or 5G system options, this is different from the 5G standalone, which basically means a 5G radio solution that is not combined with a 4G. So it's a standalone 5G. That's one concept. Here, what we are referring to is a standalone non-public network, which means it is not sharing any resources with the public network. It's a completely isolated 5G system, specifically designed for the factory or wherever the operation of the OT network is. NPN, PNI NPN, Public Network Integrated NPN, is one option where we have the user data isolated and kept in the premises industrial network, so that data, operational data, is still isolated, but the control plane is implemented together with the public network. Basically, all the core network components to establish calls, to manage identities and credentials and connectivity to the public network are managed through the public network infrastructure. The third option is a much closer integration with the public network, and that's called the NPN as a service. Basically, the whole factory 5G industrial network is hosted by the public network as a virtual or partly physical network that is isolated from the rest of the public network. So the radio components can be shared with the public network, but that's not a requirement. They can be physically isolated as well. However, if not, there is virtual separation through slices and other means to isolate the operational data. These are the three non-public network scenarios that we in 5G-ACIA and more generally in 3GPP have been working on. Now, if we compare which non-public network scenario is most suited for OT deployments, as I said, of course, it depends on the specific situation on the ground, but generally, when we compare SNPN, standalone non-public networks, to public network integrated NPNs, we see that SNPNs are highly isolated. Trust domains are similar to legacy OT deployments that we have just discussed. Flexible authentication and credential management options are available, which I will go into the details very shortly. And it's a relatively low effort for OT network regulatory compliance because it is easier to establish an isolation profile similar to the current situation. PNI NPNs, on the other hand, provide limited isolation, often virtual. Multiple trust domains need to be considered because the 5G telco operator will be present to different levels of integration. You have to use fixed authentication methods and credential management options as required by 3GPP. Because the public network is involved, all the 3GPP requirements apply, and medium effort for OT and PLMN regulatory compliance because of first the fixed authentication methods you have to use, and if your endpoints are on the public network, you have to comply with the public network regulatory issues. And on the OT side, you have to show that there is proper isolation and all the data flows are accounted for. Therefore, there is some more work to be done for compliance. As a result, we see that SNPN deployment scenarios are currently a closer match to OT legacy networks. But developments are continuing, and there are, let's say, enabling technologies being developed for PNI and PNs as well. As I said, the authentication and credential management is a key component of 5G networks. And when NPNs are implemented, they become subject to these requirements. However, there are differing levels of formalism. When you are using an SNPN from 3GPP release 16 onwards, you can use different authentication and credential management options. 5G-ACIA, EAP-ACA Prime, or any other key generating EAP method, for example, EAP-TLS, can be used in SNPNs. These terms are, let's say, quite detailed. They refer to industry best practices, and the detailed explanations we cannot give here, but I have included a reference here on this slide to a recent white paper that was published that goes through a comparison of available authentication methods. So if you're interested, please have a look. In the SNPN case, there is also a relaxation of the credential storage method. So if you are using, if EAP-ACA and EAP-ACA Prime are not used, for example, you're using EAP-TLS, the choice of credential storage is flexible, which means that you are not bound to use a USIM on the UE. UICC and USIM are being used interchangeably here in general conversations, and that SIM card doesn't have to be there if you are using, for example, EAP-TLS, which is a significant relaxation. But if you are using PNI and PN authentication, then you have to use 5G-ACA or EAP-ACA Prime as a mandatory feature, and then a USIM is a requirement. We come across authentication and credential management very often in discussions of operational aspects of 5G industrial network implementations, and it's important to get a good, solid understanding, and this reference will be helpful. Now, in OT networks, of course, network operational data is of paramount importance. We saw in my colleague's presentation. And there are multiple mechanisms in the 5G system for securing OT network data. And we are referring to the user plane data here. And when we look at the available mechanisms, network slicing in 5G is a major feature. Separate user plane per network slice ensures isolation and also gives the possibility to optimize performance per slice, as well as security, let's say, features and functions. These are virtually different networks sharing the same physical resources. There is also a concept called data network separation. There is a specific 5G system term called DN, the data network. And while you share the user plane, physical user plane, without the creation of network slices or even with, you can restrict access to different network segments. Basically, UEs and data flows can be assigned to different network segments. It's another way of implementing isolation. Then we have the LAN groups. Only UEs belonging to a defined group allowed to communicate with each other. So this helps also create the need to know implementations. Then we have traffic filtering. The UPF, which is an important feature of the 5G system or a component of the 5G system, user plane function, can filter packets on a per stream basis based on the source and destination addresses. And this gives also another level of traffic filtering and a method of isolation. So while physically sharing resources, all of these features help isolate data networks. With the inclusion in the IT domain of cloud services in most of our operations today, we are getting used to virtual separation of networks and data, and these mechanisms can be seen as an extension that in the ICT networks or OT telecom infrastructure, we have similar mechanisms to isolate data. If we go into, let's say, network slicing security a little bit more, what we see is that it's a way of implementing this fundamental requirement that we are isolating virtual networks. Now, when we implement that, it has to be a robust solution that ensures isolation is absolute. If there is leakage between isolated slices, if there is an attack possible from one slice to the other, this also breaks the system and erodes trust. So just like in cloud systems that we need a good solid isolation between tenants, it's the same applies here, that network slicing must be secure. Release 15 of 3GPP 5G system requires authentication and authorization for slice access, which was included in the primary authentication using specific slice-specific identifiers. In release 16, slice-specific authentication using EAP framework, using a slice AAA function was introduced. So there is a secondary authentication that is specific to each slice, which brings a bit more, let's say, assurance. And there are more control options to NPN slice tenant for access control this way. So the tenant, if, for example, this is a public network integrated solution, then we can give assurances of control to the slice operator. Let me speed up a little bit to let some time for your questions as well. Another enabler of security is QoS, flow separation and traffic filtering, which is basically not a security feature in itself, but QoS also ensures the much needed, let's say, traffic type separation in OT networks and helps implement OT network zones with different QoS. And that's why we wanted to include it here. and each flow in the network can be treated according to a predetermined QoS, and then also traffic filtering and QoS flow separation adds on to the 5G security features. There are new 5G-ACIA white papers coming down the pipe shortly, and they relate to QoS and also some analysis of 5G capabilities, including security and other functions. Now, in 5G release 17, there is an important feature that we are working on that's called the UE Onboarding and Provisioning, which is an important feature for industrial networks to, let's say, automate and ease the inclusion of UEs on the factory floor into the network without using elaborate mechanisms. Basically, it's solving the chicken and egg problem of first connection to the network. Devices can be, let's say, pre-programmed at the manufacturer and that do not have a, let's say, subscriber profile, but they can implement this first authentication during with some default credentials, and then attach to the network accordingly. And this sort of implements the plug and play functionality in OT networks. Excuse me. Now, there is also another function which is called in release 17 of 5G, external entity, which is a central credential holder that holds the authentication data and can implement this function for physically separated networks. And this is basically helping the distributed factory operations make use of a central deployment implementation, so that our AUSF, which is used, the network element used for authentication, is doesn't have to be deployed in each SNPN and managed. So if you will, that's a feature that eases implementation. This is my last slide. So basically what we are seeing is that 5G has a well-developed security toolbox, and that toolbox can be integrated with the existing OT security operational aspects, but just the toolbox is not sufficient. We need implementation guidelines, best practices, and applicable security profiles to make 5G security implementation easier for OT networks. And event and incident monitoring, auditing features have to be included. And also, we still have some way to go to advance radio level jamming mitigation. All of these developments require working together from both sides of OT and ICT domains. And we are working on this through 5G-ACIA and 3GPP as well. As an outlook, we are in the process of finalizing release 17 of the 5G system, and we are looking into starting the phase for release 18, where we will still work on additional security features, on network slices, on TSN, and enhanced control plane features. So the work continues to augment 5G security. And also in 5G-ACIA, there are new work items coming up regularly. And one of them is a very interesting one on network exposure capabilities. So the work continues, and we hope that 5G industrial networks will be secure for and fit for purpose for industrial operations. Thank you very much for your attention. And now we can switch to your questions.
Yeah, let me take over. Thank you very much again, Ali and Ido, for the very good and detailed presentation. In the Q&A session, as I said, I looked already into the chat and Q&A window. Currently, we have there at least one question, which I will read first, and then maybe both of you can give your feedback. So the question is, which security aspect and solutions are covered by the 5G core and NFs? And the second part is, and which must be implemented with external equipment?
So when I guess, let me take a first shot, and Ido, you might add. The 5G security features that we refer to in the 5G system are implemented through, let's say, the 5G components. We have the access network and we have the core network functions in 5G, and authentication, network slicing, all of these functions are implemented in 5G components at the network layer. My colleague mentioned, of course, defense in depth. So when we have the 5G networks security solutions at the network layer, one can still implement additional security features at the higher layers, at the application layer, and which can implement end-to-end encryption on OT equipment and servers and user end. Ido, would you like to add anything?
Yes. For an external equipment which would be needed, I think so. As my colleague Ali mentioned in the last slide, visibility of communication is quite important when we adopt wireless technologies, and so with an assumption that organization who operates a 5G network and an organization who operates an OT system different, and a tool so a tool is needed to monitor the status of the 5G system, including the status of the sessions and the flows of the information within the system is needed, and so the 5G system should provide some interfaces to implement those type of tools, and yeah, actually 5G system already has some exposure APIs, and Ali also mentioned that we are 5G-ACIA has already published some white paper describing the requirements for such an exposure interfaces, and now 5G-ACIA proceed with security aspects of the those in using these exposure interfaces. Yeah, so that is a essential part for OT operation.
Thank you very much for the answers. We have another question, so I will read it again. So the question is, what is your take on ESIMs and ISIMs for private 5G networks or NPN 5G? And the comment is also, this is with reference also to public-private 5G roaming. So what is your take on ESIMs and ISIMs?
Thank you very much. Very relevant question indeed. And as I said, depending on the conformance or let's say requirements based on the network type you choose, there is a different answer. And basically, as 3GPP has been had been focused on public networks, and the authentication mechanisms and credential mechanisms being developed there were geared towards public networks. Now introducing industrial networks and enterprise networks requirements takes some time for adaptation into the existing mechanisms. And we work in different standards organizations. Of course, 3GPP does not cover everything. It refers to other organizations specifically for the UICC and SIM solutions, this being ETSI, SCP, or GSMA, and where there are different working groups working on these questions. And when you are focused on a standalone NPN, eSIM, iSIM options are, let's say, freely available. And when you are looking at a public network integrated solution, to my knowledge, the latest is there are some developments in, let's say, using eSIMs in different scenarios, but the adoption is not complete yet. So if you are using a standalone one, these new developments are okay, and you include them. For public network integrated ones, we have to still resolve some concerns. And in the, let's say, physical world, of course, roots of trust are, let's say, ongoing implementation issue, because you have different roots of trust in a, let's say, component based on different applications. You have one root of trust, the UICC perhaps, the SIM, eSIM, for authentication to the network, and you have another one for, let's say, the applications. How do you combine and work them together, as we have seen in the, let's say, picture on the OPC UA implementation. So there are different solutions. Hideo, do you have something to add? Or Uwe? Yeah.
No, maybe we have two more questions.
Okay,
if okay, Hideo, I would ask you this one, but let's see if it's the right one for you. So we get even several more now. So if we apply both 5G user plane security and end-to-end security at the application layer by the OT, does that not add any delay or complexity to the time-sensitive OT services?
Oh, yes, and yeah, it is a good question. Yeah, first of all, so if we are talking about the OPC UA framework at the application layer security features, and this technology, OPC UA framework, uses a very standard, common security technologies used for not only for OT but also for web technologies. And so, first of all, we can expect some hardware offloading because it's a quite common security features. So that is the first one, and this issue, I mean, the more delay with the multiple layers of securities could also happen for cable networks. So let's, for example, if you use TSN network and on top of it use OPC UA security framework, then it could also be able to happen. It may happen, but currently OPC UA FLC group is working on the overall design when we use OPC UA and TSN technologies for the field level. I mean, the various latency sensitive communications between controllers or between controllers and devices. And actually, I'm not an expert for this, but this aspect is heavily studied in this group, and they will publish an acceptable framework, which is called OPC UA-FX standards soon.
Thank you very much, Hideo. We have even two more questions, so maybe at least answer one, or let's say the second is more also to get more information. So maybe Ali, to you.
Mm-hmm.
If one configured the 5G network so that each slice constitutes a different security zone,
Mm-hmm.
how would a 5G solution for the conduits look like?
Mm-hmm. Well, indeed. Mm-hmm. There are different implementation options, and as Hideo was also showing, each slice can either you can have different slices for each zone, or you can have different multiple slices crossing different zones going through different conduits. Both options are available, I think. But Hideo, do you have any other view on that?
No, thank you.
Okay, good. I said that the last one is maybe to get more information, and maybe we can even give this also later. This was more, thank you for the nice presentation. So thanks also back. Is there any insight in radio jamming problem? Because this was also mentioned with 30%, if I remember correctly. And is there any further more information to read about it? So if we can't answer it now, we can send it also later.
There is ongoing activity, of course. We are bound by the physical reality of radio networks, but in specific cases where factory floor is analyzed and the positioning of radio equipment is organized accordingly, that provides some relief. And also, I think what is key is that any jamming attacks can be detected relatively straightforwardly. So that aspect of security, that you don't remain obscure, is a key contributor, that any radio attack can be detected and mitigated. But of course, there is a limited response. There is not an absolute response. And our radio research colleagues are working on this in 5G Advanced and also going forward to 6G. We expect significant developments in this area. Thank you for the question.
Thank you very much. I would say there are more questions coming on, but this we will answer then afterwards, as we are already 3 minutes over time. So I would say thank you very much again, Hideo, Ali, for your very nice presentation. As said, we got very positive feedbacks also in the chat. Same from my side. So thanks a lot. And with this, we will end this web seminar. Thank you everybody for participating, even a little bit over time. So have a nice day. Thank you very much from 5G-ACIA.
Thank you from our side as well. Goodbye.
Bye.